Hi again. Okay, I'm going to finish up with section 2.5. I did the whole thing, wrote the last example, and then I went to post the video on YouTube and realized that for whatever reason, the last example did not record. So there is some writing in it. I already saved the document. I'll just have to talk through the last example. However, as usual, please watch this. Please try the homework. The notes should cover a lot, but you're going to have to put some of the pieces together. So just make sure when you do the homework, you ask follow-up questions on the discussion board, or you're welcome to email me to ask for an appointment if you think that that might be better. Okay, so last example was example number 5, and it asked us to find a value k to make the function continuous everywhere. All right, it's kind of a spoiler alert on this, but I'll still go through it. So we're given the piecewise defined function f of x equals k of x when we're looking for where x is between 0 and 2. And we have 3x squared for where x is greater than or equal to 2. All right, so first we need to figure out where can this function potentially be discontinuous? Well, we have to remember a couple of prereqs things. So first, thinking about 3x squared is what we call a polynomial function. In algebra and pre-calc, you learn that polynomial functions are always continuous. So I know I'm not going to have a problem with the 3x squared. All right, with kx, the x is to the first power and k is just some number. So that is also a polynomial function, which means it's not going to cause problems either. The only place where we could have a problem in this function is where that split point is. So where there's a break in the definition, and that's because if our x function doesn't meet with our parabola function, so if they don't match up together, there could be a break, which means we have discontinuity. So what we have to make sure to do is find the k value that ensures this isn't going to happen. So the first thing we need to do is consider that potential breakpoint, or you could call it a split value, which in this case is where x equals 2. It's where this interval, this definition is split. After that, we want to see, okay, well, what do the functions look like, or what do they kind of look like at the split value? So what we do is plug in the split value, which means I plugged x equals 2 into each part of this piecewise defined function. So that got me to 2k and to 3 times 2 squared, which is 12. Okay, the next thing we have to do, which I sort of showed you visually in the air at least, is make sure that the ends of these functions meet up so there isn't a hole or a gap in the overall piecewise defined function. Computationally speaking, what this means is that we have to make sure that they're equal to one another. So what we do is we set the pieces equal to one another, right? I did this on the left over here. So 2k equals 12. Solve for k to get 6. Now, if you're thinking, oh, that's kind of weird, I'm not sure if it's right, you can actually check. So in the check step, in this green part right here, I just plugged 6 in for k to get 6x, and then I still have the 3x squared there. So first, this scraggly looking blue line is supposed to be a straight line to represent 6x, and then this piece right here is my polynomial. So that's the 3x squared, and I see that that's 12 there. So this does in fact close that circle like I wanted it to. I don't have a gap between the two functions, which means that I do have continuity. All right, so sorry I had to break this up a bit, but that should be enough to get you going on the homework. Please try it. Please ask questions as you have them. Thanks.